Good morning. How's everybody doing today? Welcome to the broadcast. I see we got a couple of viewers today. How's everybody doing? If you would, go ahead and check in and say hello. Who we got in the audience here? Uh-oh, you know what I need to do in order to set this? Hold on just a second. Let me set a technical thing. Stream settings. Okay. Well, good morning. I hope everybody's doing well. I have my stream settings on the high latency, so it'll take a while for me to get your comments. But it's good to see you, Donnie. It's good to see you, KB. How's everybody doing today? Okay, so yesterday and Monday we spent time talking about behaviorism, and I suggested to you that it was an anti-mentalistic movement in psychology that thought that the best way to understand how humans function was to look at how the environment shaped their behavior. And they thought that everything that we took for granted as uniquely human and uniquely mentalistic as being a product of two forces, classical conditioning and operant conditioning. And they argued that very complex behaviors could be could be created using the technique of shaping. And so these people believed that this was the best way to think about human functioning. Now, in 1947, this cool thing called a computer was invented, and this brought on the cognitive revolution. So today's lecture is going to be all about cognitive psychology. And so what we're going to do is we're going to talk about cognitive psychology as an information processing approach. And then I'm going to give you a description of the what we would say is the most popular conception of how our mind works, the Atkinson and Shiffrin model of memory. And then we're going to spend a few minutes talking about how you can improve your memory to have a more durable memory. Okay, so let's talk about the information processing approach. Now, before, I guess, the mid-1940s, there were a lot of people who really believed that human brains all acted uniquely and distinctly. So my mind works one way, your mind works another way. In fact, William James even suggested that measuring the mind was like trying to measure the water in a stream, and that's where he came up with that stream of consciousness concept. And so the idea was the belief that human beings didn't engage in these systematic processes and that they weren't universal for all of us. Now, in the late 40s, this thing called a computer was invented. Basically, that's a information processing machine. And this sort of made it painfully obvious that we needed to think about human beings as having a set of programmed instructions that are in our brain that focus on how we use information. And these people came up with, they birthed cognitive psychology, which is a study of how human beings encode, store, and retrieve information. This approach started in the early 40s before we had any idea of how to measure some of the more specific neurological details inside the brain. But I will tell you a more common approach now is what we call the cognitive neuroscience approach. And so these people are interested in looking at how we encode, store, and retrieve information with a focus on trying to explain biologically how this happens. So you can be a cognitive psychologist, or you can actually go in and join a cognitive neuroscience program. Now, this approach was inspired by dissatisfaction with the behavioral approach. Behaviorists suggested that we throw out the baby with the bathwater, just because studying the mind is a little bit difficult. They just said, well, you know what, let's just not study the mind all. And also with this invention of the computer, which really the programming instructions, what you would call the program of a computer, the operating system, really made it fundamentally believable that maybe human beings have an operating system inside them. So one of the things I want to start off by talking about is how computers and human information processors are similar. In fact, there was actually a cognitive manifesto written in 1957 about the beliefs of the cognitive perspective. And these people suggested that the computer served as a fundamental analogy for understanding human information processing. So whereas a computer receives input, we talk about human beings encoding information. If you're paying attention to me right now, information is being encoded in your short-term memory. If you remember what I tell you today and can reproduce it for me tomorrow, that information has been encoded in your long-term memory. So encoding is a term we use to refer to getting information into a memory store. Then we talk about information being stored there. Now we really still to this day do not know exactly how neurons store memories. What exactly does a memory of a rabbit look like in your brain? We don't know that yet. What exactly does a memory for George Washington or how to do a mathematical equation, how is that stored in brain tissue? We don't actually know that. But we do know that the information is stored in the brain, and we know that that's different from retrieval because we've all had the experience of knowing that we know something, but not being able to remember it at a specific time. So when we talk about humans, when we talk about output in computers, we talk about retrieval in humans. So we engage in encoding, we store material, and we also retrieve it. And these are three fundamental processes that you can say that human beings engage in. Now, why is this important? Why is this important? Well, here's the deal. You can't actually see inside the mind. It's a black box, if you will. So, in order to learn anything about your mind, what I have to do is make some basic assumptions about what must be going on. If you can tell me who the first president of the United States was, then I assume that you must have encoded that. You must have heard that and paid attention to that at some point. You must have encoded that material. You also had to store that material, and you also had to retrieve that material. And what they do in the cognitive approach is they test your encoding, your storage, and your retrieval abilities to kind of figure out how they work. And using knowledge about these three processes, they can begin to build a model of what must be happening inside your mind while you're processing information. I hope that makes sense to everybody. Okay. So let's move on with the next part of the lecture. Okay, so I'm going to spare you the gruesome details about how it was developed, but I will suggest to you that the current model of the mind suggests that human beings engage in three basic processes or have three basic memory stores, if you will. Now, these stores may not necessarily be places, but they are activities that our brain engages in. And this very famous model was developed by a couple of researchers, and it's become known as the Atkinson and Shiffrin model of information processing, or the three-store memory system, whichever way. And so I'm going to argue that all information that comes in through your system goes through these three processes. It goes through what we call a sensory memory, which is pre-conscious processing. This is where you see things before you actually pay attention to them. And this is a filter that we have in our mind that allows us to scan our environment and decide what it is we want to pay attention to. So this is sort of where things go before you are really aware of them. And you know what? We learn through experience what things to pay attention to and what things we can ignore. I don't know if you remember this from several days ago. Do you remember when we did the dancing bear experiment in consciousness? And I asked you to look at the people throwing the basketball and to count the number of passes made by the team in white. And 50% of us did not see the dancing bear. What I would argue is that all of us encoded the sensory bear in our sensory storage, but most of us decided not to pay attention to it. Think of your sensory memory as a filter. Right? If you've ever been to a cocktail party or a party, you notice you can block out the entire room and just focus on the person you're talking to. And people can be talking and you still won't hear what they're saying. But if somebody mentions your name, that seems to pop through your ear and you can turn because you've heard somebody else say your name. This thing called the cocktail party effect has been shown to be true. People who are asked to ignore an ear won't hear anything that comes in that ear unless it's their name. And why do you think you would always pay attention to your name anytime it breaks into your sensory memory? Does anybody know why? I'll give you a second to answer. Type in your little answer. Because that's the most important sound you hear for your entire life. So of course, sensory storage deletes out white noise. Wow, KB has a really good way of thinking about it. Sensory storage actually deletes out white noise because our ability to pay attention to things is so limited that we have to learn how to not pay attention to other things. All right, so that's the first memory store. Now, let's say you decide to pay attention to that dancing bear, or to my lecture, or to your name. That information is then encoded in your short-term memory. And this is your conscious awareness. This is exactly what you're thinking about right now. No, what you're thinking about right now. No, what you're thinking about right now. Do you see my point? It's whatever is in your mind at a given point. Let's say I wanted to give you a list of items to pick up from the grocery store. I need you to pick up bananas, taco shells. We need shredded cheese. I need sour cream. Can you pick up some dish detergent? All of these things, right? I'm asking you to juggle a bunch of things in your mind. How many of you are good at remembering a list of things, right? This is where information is when it's in your short-term memory. It's your conscious awareness. Now, as I suggested to you earlier, your ability to pay attention to things is fairly limited. So this short-term memory is kind of small. In fact, we suggest that you can only keep 7 plus or minus 2 chunks of information in this particular memory store. And this information will only be in there as long as you are thinking about it. Once you stop thinking about that list of words that I said, the list of grocery items, that information will begin to decay out of your short-term storage. How many of you forgot the list of grocery words that I just asked you to pick up? What do I want you to get from the grocery store? I bet you probably already forget it. We don't do grocery lists verbally if over 3 items. There you go. That's my old man brother, KB, talking to me. Absolutely, right? You and I, the only difference between you and I and the younger kids is we know that our memory stinks, right? And so your short-term memory is what you can keep in your mind. You can keep about 7 plus or minus 2 chunks, and the encoded information will quickly deteriorate if you stop rehearsing it. Now, I'm going to use a term rehearsal. Let's not use thinking about stuff or consciously processing. Let's say while you are listening to the words in my sentence, you are rehearsing them in your short-term memory. If you remember that list of words that I gave you, the list of grocery items I gave you, you are rehearsing it in your short-term memory. So I got to pick up taco shells, cheese, shredded cheese, and sour cream today for dinner, and I need bananas for myself, and then my wife wants some dish detergent. So I remember those 5 things, but that's because I've written them down and thought about it for a while, right? So rehearsal is actively manipulating information in your short-term memory. Does that make sense? Now, it turns out we have a third part of our mind. Let's call this the long-term memory. If you will, please tell me, what is the answer to 3 plus 2? If you remembered that, you know that the answer is 5. You weren't thinking about the number 5, but you retrieved that out of your long-term memory. If I asked you who the first president of the United States was, you would say George Washington. Now, you weren't thinking about George Washington a minute ago, but it was his name was in your long-term memory. Your long-term memory, or what we call our memory, is the unconscious storage of information that we will use later on. It's the store of all the things you can call into your short-term memory, right? Now, whether or not something gets encoded into your long-term memory depends on the type of rehearsal that you engage in while the information is in your short-term memory. So if you see I have rehearsal here up under short-term memory. Depending upon how you think about things, you will have better memory for them than other ways. So one of the things that I find with students that aren't as good at testing is that they haven't developed their memory strategies. Now, I'm going to talk about it in just a minute, but I want you to know that knowing how to remember things is not something you are born with. It is a skill that you can develop through practice. I promise you, I promise you, I promise you. I have 81 students in my class. Now, not very many of you will make an A in this class because you're not going to remember stuff on the test. But I will tell you, out of 81 of you, I'll bet at least 60 of you could pass law school or go to med school if you develop your memory abilities. Memory, your ability to put things in your long-term memory, depends upon the conscious form of rehearsal that you engage in. Okay? In KB, you could remember a grocery list of 20 items if you just practice your memory strategies a little bit. Okay? Excuse me. So what I'm going to do really quick is I'm going to go through and make 3 points, brief points. I've got 3 slides, and I'm going to make some points about each of these memory stores, okay? So the first thing I want to point out to you is that your sensory storage is this filter. And human beings, anytime you look at something, so you're looking at me right now, and you're noticing the color of my shirt, it's blue. You're not noticing how short and gray my hair is. You might be noticing the chat bar in the screen. You have all of these different things that are in your sensory experience, but you are going to decide what it is you pay attention to, right? Now, this filter is trained over the course of your life as people tell you what to pay attention to. And by the time you get to my age and your age, you already have some well-learned biases of the information that you're going to let through your sensory memory. So here's what I would like you to do. I'm going to do a little demonstration of this. When I click on this next slide, you're going to see a list of words printed in colored ink, okay? What I want you to do is ignore the words, and tell me the color of the ink that each word is printed in, okay? And you're gonna go left to right, top to bottom, just like you're reading, but don't read the word, tell me the color of the ink that the word is printed in. I hope everybody understands that, right? So, with further ado, 1, 2, 3, go. Okay, so what did you notice about that? I'll bet you probably noticed that it was hard to say the color of the word because you were too busy focusing on the semantic content of the word. So the correct answer for the first word would have been red, but I'll bet your brain wanted to say purple. The correct answer for the second word would have been blue, but I'll bet your brain wanted to say yellow. And the weird thing is, this thing's called the Stroop effect. when they ask people to read these words out loud, they find that people are much slower reading this list of words than they would be if we had a bunch of words not related to color that were printed in these different colored ink. So if instead we had bird, car, antelope, pizza, etc., you would probably find it much easier to pull the colored information out of the word, right? And so what this demonstrates is, and why would this be? Well, I would argue that this occurs because you have been trained over the course of your life that it's the semantic information in words that matters, not the color of the word. It's the semantic information that really matters. And so the Stroop effect demonstrates the sort of filter nature of this thing called the sensory memory. Now, chunking. Here's the deal. It turns out that I can overwhelm KB's short-term memory by giving him a list of 20 grocery items to pick up. And you know what? If I gave KB 20 words, he would not remember all of them. As he said, he would probably remember somewhere between 5 and 9 of these grocery items. And what you're going to find is that he will be most likely to remember different parts of the list. He'll remember the first 3 grocery items his wife gave him, or he'll remember the last 3 words on the grocery list that he was given. So this is known as the serial position effect. When you stress somebody's short-term memory by giving them too many words to remember, they usually forget the middle of the list. Now, here's the deal. What I want you to know is that your short-term memory can hold 7 plus or minus 2 chunks of content. This is actually a hard and fast limit. This is called Miller's magic number because a guy named George Miller was the first person to identify this. However, chunks can be of any size. If you think about it, the word cat can either be 3 chunks, a C, an A, or a T. But most of us put those letters together into one large concept called cat, right? So what you can do is you can artificially increase the size of your short-term memory by learning to chunk things as they come into your mind. So Ken, the reason I'm able to remember this list today is because instead of thinking about taco shells, cheese, sour cream, I'm instead thinking taco dinner. So I put those 3 things into one large chunk. And so if I did that with 21 words, I could remember all 21 grocery items by chunking them into groups of 3. And so then I've got the salad because I also need lettuce, tomatoes, and I need bananas. Because I like bananas. All right, so I've got banana salad is my second chunk. So I've got 6 words, right? Tacos, cheese, sour creams, banana, lettuce, tomatoes. That's 6 words, but I've decided to chunk it into 2 chunks. I'm thinking taco dinner and banana salad, right? Do you see how I've artificially sort of increased the size of my short-term memory? Now, it turns out that your short-term memory is positively correlated with your reading comprehension. Duh, the more sentences you can keep in your mind at one time, the better you'll understand what it is you're reading. It turns out that your digit span, the size of your short-term memory span, is positively correlated with your reading ability. You may or may not know this, but IQ tests actually evaluate the size of your short-term memory. On an IQ test, it's called your digit span. And what they do is they test you with numbers. They read the numbers forward and they read the numbers backwards. And they keep getting the list longer and longer until you fail and can't remember. And then that's sort of the size of your digit span. Now, here's one of the things you can do. Notice it's written in blue because it's optional. If you don't want to do it, it's up to you. I'm just telling you that it would be useful. What you need to do is you need to practice chunking information that you are given to in order to improve the size of your short-term memory. As I mentioned, this is not a natural ability. This is a learned ability. So the first time you will do it, you won't do it well. Think about it. The first time you tried to play pool, you didn't do it very well. The first time you tried to ride a bike, you didn't do it very well. But after you practice these abilities, you get good at them. So practice chunking, and over time, you will get into the habit of developing a much larger short-term memory. And having a large short-term memory will allow you to remember things and keep things in your mind so your intellectual functioning is better. Any questions so far? Now, I then want to talk to you, so that's the short-term memory. Now, I want to talk to you a little bit about improving your long-term memory. And the quality of the long-term memory depends upon the type of rehearsal that occurs in the short-term memory. Now, if you'll look at the picture on the right, it sort of shows you a schematic of how your mind is most likely organized. You have these things called schemas, which is a knowledge structure that contains all of the associations that you have with a concept. If I asked you to write down the first 10 words that come to your mind when you think of the word circus, all of you would be able to do that, right? And so you'd start writing down lions, tigers, bears, clowns, you know what I mean, elephants, popcorn, peanuts. You would start writing down all of these associations. This is what we would call a circus schema. And if you think about it, stereotypes that we have are nothing but beliefs, associations that we have with a given person or group, right? So if you think of athletes as being dumb jocks, that's a stereotype or an association that you have with a concept of jocks. Now, schemas are tied together through what we would call association networks. So if I say, what comes to mind when I say circus, and you say, let's say, you say clown, okay? And then I say, ooh, clown makes me think of birthday party. Now, why would clown make me think of birthday parties? Because you know what? The schema birthday party would include cake, presents, people, and it might include a clown too. So if you think about it, those two schemas tie together through the association of a clown, right? So that's called an association network. Here's the deal. If you want to get something into your mind, don't think about it by itself. Relate it to something that's already in your mind. Does that make sense? So, some people like to study by reading things over and over and over again. Students will have note cards where they'll have the definition and the word. And they'll read the word, then they'll read the definition. They'll read the word, they'll read the definition. You know what? That's maintenance rehearsal. All you're doing is just repeating the information over and over and over again. That does not create a strong memory trace in the long-term memory. Instead, what you need to do is relate it to something that's already in your mind, okay? So, I have a friend, his phone number starts 776. His phone number is almost, I won't tell you the zip code, or the area code, 776-1066. Now, you know how I remember his phone number? 776 reminds me of the Revolutionary War. So when I try to think of the first three numbers, I relate that to the Revolutionary War. Now, I'm a history buff, so I know that 1066 is the Norman invasion. When I think of my friend Linwood's phone number, I don't try to remember all 7 numbers. I just think of 2 things that I already have in my mind: the Norman invasion and the Revolutionary War. You know, I know it sounds weird to you because those 2 things aren't in your mind, but the idea is if you use things that you already know as a scaffold to elaborate to, you will find that your ability to remember things gets much better. So instead of just reading a definition over and over, relate it to an experience that you once had. So you can say, wow, I remember when that happened. And that association uses elaborative rehearsal, and it'll probably create a stronger memory trace. Okay, in your book, they have an overview of the 3 memory stores, and this sort of represents the knowledge that I want you to abstract from the lecture that I've given you. You have this sensory memory in which stuff lasts only a couple of seconds, and it allows you to, it's based on your sensory experiences, and it allows you to decide what you're going to pay attention to. That information then goes into your short-term memory, where it lasts about 20 seconds if you stop thinking about something, and it allows you to keep 7 things in your mind as long as you're rehearsing them. And then I want you to know that we have a long-term memory storage. And you know what? Your long-term memory storage is probably unlimited. I mean, I'm sure there's a limit to how much we can remember, but we've never figured it out. And you know what? Sometimes people remember things for their entire life. So it's probably unlimited in duration as well. All right, here we go. We're 11:30. I want to give you 5 minutes of tips to help you as a student. All right, here's how to improve your memory. And these tips come from page 258 of your textbook. And you may not like these tips. This is kind of like if you want to be healthy, you got to eat your vegetables. If you want to lose weight, you have to burn more calories than you take in. This is hard advice, but if you follow what I'm telling you, you will do better in school. Number one, this guy named Hermann Ebbinghaus, actually in 1896, I think it was, found out this very important concept about the memory. The first time you memorize something, you will forget half of it, half of what you learn within 1 hour. I can't tell you how many students tell me that their memory is flawed because they forget half of what they learned within an hour. I'm telling you, if you have this experience, then you are normal. How do you fix this problem? Well, this is what Ebbinghaus suggested. You overlearn. If you look in the graph right here, each of these lines represents a time that he learned a list of nonsense syllables. The red graph is the first time he learned it. And you'll notice that within 1 hour, his memory is already down to 50% of what he had learned. But he went back and relearned the material a second time. He found he learned it quicker, and the curve of forgetting, his forgetting curve was less steep. He went back and learned it a third time. He went back and learned it a fourth time. Now, why does this work? Well, there's this process we call consolidation. Anytime you think about something and engage your hippocampus, all right, you are consolidating that material. You are creating a durable memory trace. The reason we don't remember our dreams is because we don't activate the hippocampus and our dreams are not consolidated. So they float away and we never remember them again. But if you really focus and elaboratively rehearse something, your hippocampus will become active and you will consolidate that memory. Won't be perfect, but you will improve it. You remember some of it. And then every time you access a memory and bring it back up into your consciousness, your hippocampus is consolidating that memory. And we call the second and third and fourth times you think about something as, we call that reconsolidation. So the bottom line is you need to bring stuff up into your consciousness multiple times in order to really create a strong memory trace. The first time you try to remember something, you're not going to remember much of it, but that's normal. The second time you think and study, your memory will improve. So let's say you're going to study 3 hours for a psychology exam. Better than studying one time for 3 hours is to study 3 days in a row for 1 hour each. This is what we call the distributed practice effect. Does that make sense? And the idea is just every time you bring it into your awareness, again, you're consolidating, you're activating that hippocampus, which helps the memory become more and more durable. And you know what? If you reconsolidate it enough, like George Washington, you will never forget that dude was the first president of the United States. You can't forget it. It's just in there. You know what I'm saying? Now, the second thing you can do is use what we know about your mind. Your hippocampus is really good for spatial location because memory is about finding food, right? That's why we develop memory, so we would know how to find food and how to avoid dangerous things. And so your amygdala tells you what you like and don't like, and your hippocampus tells you where it is, all right? And your temporal lobe actually stores images, not words. If you think about it, your memory evolved long before language developed. So we study pictures rather than words. So using that three knowledge, location is something that we easily learn, emotional things are more easily learned, and pictures are more easily learned. If you know that, then what you can do is you can use these neurological strengths of your brain to store memories more easily. Now, a mnemonic uses the power of schemas and humor to create Associations in the temporal lobe. I'm sure all of you know, please excuse my dear Aunt Sally. That's the order of operations for math, right? If you're a musician, you probably learned every good boy does fine. That's the notes on a clef, a musical clef. I don't even know what that is. And I learned in 7th grade, I learned how the orders of classification. My teacher taught me Kathy pulls candy on Friday, good stuff. Kingdom, phyla, class, order, family, genus, species. I learned that. Mnemonics take into account the fact that letters themselves are part of schemas. When you think about the capital of Idaho, you may not be able to tell me what the capital of Idaho is until I tell you to think about the word B. And then suddenly you go, oh yeah, Boise. Letters are actually part of schemas and they can act as memory triggers. So make up mnemonics. You can always make up. Nobody says it has to have been the one that was already developed. You can invent one yourself, but make sure it's funny and has an image, right? And then the temporal lobe is evolved to store images. So really, you need to create vivid, funny images. So if you want to remember what the amygdala does, think about an angry alligator, right? I mean, isn't that a funny, just snapping, rah, 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 rah. An angry alligator with an amygdala, right? So the angry alligator amygdala. Think about an angry alligator, an image of one with the big teeth, right? Now, it turns out that our brain automatically stores location. I could ask you to recount your steps today, and you could probably tell me everywhere you've been. I went here, then I went here, then I went here, then I went here. Turns out your brain automatically stores location because if you find some food at a particular location, you need to be able to get back to that. So your hippocampus is really good with spatial memories. If you take that into account, what you can do is you can store things that you want to remember around your house as images, and then when you want to remember them, you close your eyes and walk around your imaginary house, and you will find the objects that you are looking for waiting for you. I know you think this is crazy. I know you don't believe it. So I've got a link to a video by a memory expert named Luis Angel. He was actually a community college dropout till he learned how to use his memory. He's got a great story. He was a community college dropout who then came back after he learned these memory tricks. He got straight A's in college after that and is now a memory champion and a very famous memory coach. He's a young guy, awesome, and he has two videos that I've got in your course resources folder. The first is a video where he demonstrates the method of location. It seems like a lot of work, but once you get good at this, you will be surprised at how easily the method of location allows you to remember things. And then I've also got another folder where he shows you how to remember different things, how to remember math equations, how to remember biology terms. And so he's got a lot of strategies that use these memory techniques to help improve your memory. So if you want to improve your memory, that's what you'll need to do. And I tell you, who was it today that was asking me about that? I think it was Erica, was asking me about memory cues and memory lectures, and was I going to teach you anything about how to improve your memory? There you go, Erica. That's how you do it. If you want to have better memory, you need to learn and practice these strategies. Remember, you won't be good at them at first, but if you practice them, I swear to God, they will supercharge your memory. All right, wrapping it up. The information processing approach conceptualizes the mind as a computer program, and what they're trying to do is figure out how our operating system works. The most famous model of memory is known as the Atkinson and Shiffrin model of memory, and it suggests that human beings have three basic memory stores, ways of manipulating and storing information. And finally, having good memory is not something you're born with. It's a strategy of processing and rehearsing information that takes advantage of your brain's strengths and supercharges your memory ability. Do you have any questions for me that's really all I wanted to say today. I just wanted to share those facts with you. Tomorrow, we're going to talk about how memory can fail us. We're going to talk about the different types of memories that people have. And we're going to talk about how sometimes when we try to access these things called episodic memories, which are memories for events that happen to us, our memories aren't always as good as we think. All right. If you don't have any questions for me, I'm going to let you go. It was great to see you today. Don't forget to get started on the homework. You have all day to do the all week to do the homework. And the discussion board is coming up in a couple of days. So go ahead and get started on that. If you don't have any other questions, have a great day, and I will see you tomorrow.
Your call cannot be completed as dialed. Please consult your directory and call again, or ask your operator for assistance. This is a recording.